Hey guys, welcome to Unit 5, Day 1, Normal Curve Properties and Empirical Rule. Our objective today that we can identify the properties of a normal distribution, we can explain how a change in the mean and standard deviation will affect the graph, and we can apply the empirical rule to estimate probabilities. So let's get started. So what do we need to know about a normal distribution? So normal distributions have two defining qualities. We need to know the mean, and the mean is our midpoint, right? So the mean's right here, it's our midpoint. The next thing we need to know is like, okay, how spaced out do we want our normal distribution to be? And as you can see, normal distributions are symmetrical or bell-shaped. So our standard deviation then measures our width. So our normal distribution gives us the center. The standard deviation then right here gives us how spread out we are. It's a measure of width. And with our mean and our standard deviation, we can create and interpret and solve any normal distribution. So the main idea is here, normal distributions have two characteristics. It is the mean and standard deviation. So let's see how we're going to use those. So here is an example of a normal distribution. So the ITBS vocabulary score X, so we always call things random variable X. The randomly selected 7th grade student in Gary, this is Indiana, is modeled well by our normal distribution, right? They give us our mean, and look, ooh, that's our center point, and standard deviation, which is sigma, which is 1.55. So now notice, this is plus 1.55. This is plus another 1.55. This is plus another 1.55, right? These give us our widths. They're a unit of measurement. If we go to the left, we're subtracting. We go to the left, we're subtracting. We go to the left, we're subtracting, right? So notice, to the left, subtracts by our standard deviation. To the right, adds by our standard deviation. And this is how all normal distributions exist. So we need mean and standard deviation, and that's how they're built. So if we wanted to build our own, right? So standard shape of a normal distribution is like this. I know my center has to be at 2. Now, if I wanted to build out my standard deviations, right? 1, 2, 3, we almost always only include 3 standard deviations. And here, right? And then 3 standard deviations, so that 1, 2, 3. All right, to the right, my standard deviation is 3. So add 3, so that's a 5. One more to the right, add 3, so that would be an 8. One more to the right, add 3, and that would be 11. Now I'm going left. Subtract 3, negative 1. Subtract 3, negative 4. Subtract 3, negative 7. So here is my normal distribution with mean equal to 2 and standard deviation equal to 3. That is what my normal distribution would look like with these indices down here. So let's try another one. Now, what if I shorten my standard deviation a little bit and make it into 0.3? So here's my kind of generalized normal curve. My center then will be 3. My mean is always my center. 1 standard deviation to the right would put me at 3.3. Another standard deviation to the right would put me at 3.6. Another standard deviation to the right would put me at 3.9. So there's my 3 standard deviations to the right. To the left, right, I'd have 2.7, so I'm subtracting 0.3, subtract 0.3, so this would bring me at 2.4, subtract 0.3, this would bring me to 2.1. Right, so notice this this normal distribution goes from 2.1 to 3.9, whereas the last one went from like -7 to +11, right? Much, much less of a spread here. So this normal distribution, if it was really drawn to scale, is going to be a little taller and a little skinnier, and the last normal distribution would be a little wider and a little fatter. Excuse me, longer. Oops, need my pen. So how, in fact, does a normal distribution, how does standard deviation affect the appearance? Well, a larger standard deviation makes it wider, right? Little wider, little flatter. A smaller standard deviation makes it skinny. Makes it skinny, makes it peaky, right? Standard deviation is the width. If you have a small width, you're going to be taller and a little peakier. If you have a large width, right? You're going to be a little longer, you're going to be a little wider. Now, how can I pick out the mean of a standard deviation? Excuse me, how can I pick up the mean of a normal distribution if I'm given this? Well, we always know the mean, which is given by this little mu guy, is always in the center. So if I'm given this normal distribution, I always know the mean is going to be the center number, in this case, 170. Okay, so just a little bit of how to read. If I want to say, hey, what is one standard deviation to the right? I would say 200. If I want to say, hey, what's two standard deviations to the left? Center, 1, 2, that would be 110. Okay, so just a little bit of how to read them. So we have our empirical rule. So this is either called the empirical rule or it's called the 689599.7 rule. This is how to help estimate probabilities in a normal distribution without a calculator. So what this rule says is this says for all normal distributions, 68% of the data is going to be between -1 and 1 standard deviation away from the mean, right? 1 standard deviation left and right. 95% of the data is going to be within 2 standard deviations, right? This is this light green. And the 99.7% of the data is going to be within 3 standard deviations. So you can kind of see if you fall somewhere outside of 3 standard deviations of the mean of a normal distribution, you're probably an outlier, right? Because basically everybody is within standard deviations, within 3 standard deviations of the mean. Okay, so let's see how to use this and estimate some probabilities. Also, probability and everything is just, we're looking at area under this curve. All right, so in practice. So back to our vocabulary scores in Gary, Indiana, right? We know our mean, we know our standard deviation. That is everything I need to know about a normal distribution to do anything about it. All right, I'm going to use empirical rule here to approximate the probability that a random data point falls less than 3.74. I'll say that again. What I'm trying to figure out is what is the probability that a random selected data point is less than 3.74. Well, let me set up my normal distribution, right, where I know my center is 6.84. It just helps to sketch. You don't necessarily have to do it, right? I want to know that we're less than 3.74. Okay, so 1 standard deviation here to the left, 2 standard deviations to the left, 3 standard deviations to the left. Let's see where we are going to fall. So minus 1.55, so that is going to put us at 5.29. So 5.29, so 1 standard deviation to the left because I subtracted, 1.55. Let me subtract 1.55 again. Oh, look, I'll get 3.74. So I want to know what's the probability that I fall in here, right? Because this would be less than the 3.74. So what's the probability that I fall in there? Okay, so that's the question for A. And then the question for B is what's the probability that a randomly selected Gary 7th grader gets an ITBS score between 5.29 and 9.94, right? Well, 5.29 is here and 9.94 is going to be 2 standard deviations above. So I have a better picture of this on the next slide. Okay. So for A, this is what we're doing. This is a better picture than I can draw. So we wanted to know, right, what's the probability that a randomly selected student would be less than 3.74? So we find 3.74 here, right? What do we know about empirical rule? We know about 95% of the scores are within 2 standard deviation. So between here, let me switch my color. So between here and here, that's 95% of the data, which means the remaining 5% is going to fall on both of these tails, right? Because it has to end up to 100. Okay, so the sum of both of these tails is 5% of the data. But I only want one tail, right? Because that is, here's the 3.74. I want to know everything less than that. So that is all the area to the left of that number. So that's here. 95% of the data should fall in that shaded area because that's 2 standard deviation according to empirical rule, which means 5% should be in the tails. So because there's 2 tails, that splits. So 2.5% of the data then will belong in that tail, which means my probability is 0.025 that you fall in that range. Okay, let's look at B. So B is what was the probability that we are between 5.29 and 9.94. 5.29 is here, that's 1 standard deviation. So minus 1 standard deviation away. And 9.94, that's plus 2 standard deviations away, right? There's our mean right there. All right, so we know that 68% of our data, right, according to empirical rules, 68% of our data is contained in here. Right, we know that's 68%. And then we know within 2 standard deviations, right, this whole thing, 95% of the data is supposed to be held in there. But we don't have that whole width. We're missing this section. So we only have this section and this section. So 68 minus, 95 minus 68, right, would give us these 2 spaces. Divide that by 2 because we only want one of the spaces. So that's 13.5%. So 68%, so the blue area plus the black area, so 0.815. In other words, we have about an 81.5% chance of falling in that range. That's how we use empirical rule to estimate. So let's keep going here. So how much is 9 ounces? The weight of a 9-ounce bag, so I'm going to draw this one. The weight of 9-ounce bags of a particular brand of potato chips can be modeled by a normal distribution with mean, need that, and standard deviation, need that. Let random variable x be the weight in ounces of a randomly selected bag. Use the empirical rule, also known as that, to approximate the probability that I am less than 9.02. So let me draw this. What do I know? I know my center is exactly at 9.12. What else do I know? I know my standard deviations. I know that every standard deviation puts me 0.05 away. I'm going left. So that would be 12 minus 5, 0.07. Going 0.05 again, 9.02. Going 0.05 again, 8.97, right? Because that's our standard deviation. Draw a little line here. So what's the probability that we are less than 0.092? So here's 0.092 here. I'm less than, right? So that means I take this chunk and this chunk, right? Well, how many standard deviations was that away, right? So that's 1 standard deviation, that's 2 standard deviations, right? How much data is contained? First off, we are perfectly symmetrical. So 50% of the data is contained from the midline over, okay? So from the midline over, we know we have 50. Okay, what we also know is we also know how much is contained in these 2 pieces, right? Because according to empirical rule, right, here's 1 standard deviation to the right, here's 2 standard deviation to the right. I know that inside here, right, so first off, underneath the whole thing is 1. I know within 2 standard deviations, right, there's 95% of the data contained in there. Okay, 95% of the data is contained within 2 standard deviations of the mean, which means this outside stuff has to add to 5, right? So 2.5% of the data must be contained in that tail, and 2.5% of the data must also be contained in that tail. So I only want one of the tails, so my answer is 2.5%, or put it in decimal, 0.025. Okay, B, the probability that a bag weighs between sorry, 8.97 and